Good morning. So this is Himanshu Pandey, manager of Indian Space Research Center. So today's topic is data repository for Indian lunar mission. As a part of this course, exploring Earth's moon through Chandrayaan. This is running from June 23rd. Today is the last week of whatever is planned today. So hopefully you might have gone through the entire Chandrayaan mission, Chandrayaan 1 to Chandrayaan 3 and upcoming missions of ISRO also. So today and we are seeing the science outcome also were planned for all of you. So anyhow, to understand of the mission as well as to also derive the science. Now you might have got a lot of motivation and interest to also join and work in this particular domain. So now to work in this particular domain, ultimately what you need is your ideas, concepts, tools, as well as the data. So today's lecture is how to get the data. So before starting with this is an Indian Space Science Center, which is also called as ISRO Science Center Gateway to the scientists, students, institutes, professors, and public researchers, principal investigators, best of others. So if you want to receive the lunar science data and other space science missions data from this one, you have to come to ICTC, that is ISRO Science Center. This is just a typical drone view of our site. So this is in the center. What you are seeing is our Indian Deep Space Science Center. This entire site is called Indian Deep Space Network. And here big antennas are there, antennas, now these are the deep space class antennas, and they are co-located with the Science Data Center. So the data is received from either from the Chandrayaan series of missions or from the Mars orbit missions. So that would be received here and then it is supplied here directly to the center, so that then in there it can be processed and then disseminated to the concerned PIs and POCs. And after that it will be posted from here for the general users and the center community. In addition, there are some other stations and then coming to the data center. So the main objective of the center is to facilitate data acquisition, means to receive the data from different ground stations, like Indian ground station or foreign ground station, process it, archive and disseminate. So this is the main thing of the center. The vision of the center is to extend the services for all the lunar interplanetary missions, space flight programs, science missions, and other deep space missions of ISRO with state-of-art technologies, and also collaborate with the science data centers to facilitate availability of the certificate. Just touching about on some of the points like about IRC and also the Lunar archives. It was actually established and operationalized in 2008 and at ITSN, whatever I have shown the photograph. Then till now, whatever completed missions means the design life is completed. Chandrayaan 1, then there are now Chandrayaan 3 also is listed here in this, that I have to shift it here. Then you said Megapropit and something understood. Now ongoing mission is exercise Chandrayaan 2, tank and mechanic. The main thing is, even though the design life is over and missions are completed, but for science data center, mission can work. You have to continue serving the data, you have to keep on changing the underlying architecture, the systems are keep on changing, the operating systems are keep on changing, the applications will become old, we may have to port the new applications, new features need to be enhanced, and data need to be disseminated to the scientific community and the users in such a way that this should be useful even in the longer term also. Once we go to this one top level features, so like data ingest, data archive, information already I have mentioned. Web application hosting is another primitive function, and the mission is specific data. So there are many missions, many scientific missions, they will have a different requirement of handling the science data, different processing requirements, different compute requirements. Some are large volume data sets where you need high-end systems and then high-end storage for activity. Some are smaller missions comparatively which are going to handle so like that. And then some missions for which the data generation needs some prerequisites, some other inputs. So we have to work out a different mission specific data pipelines, data flows, file format, travel standards, everything, and then implement this for the mission specific. In addition to that, for the data center, IT services in the automation. And to do that entire thing, lot of application development is also required part of science. Now slowly the another domain is getting added up to the data science analysis. In fact, this is the domain where all the students also can approach us and can participate, and once data is available, they can also, even if you want to conduct a data center and want to do a few months of activity being a data center where there is also a level system available, that is also very much possible. This is the typical for each and every domain, whether in just processing archival. There are many things which are happening here with the payload related, auxiliary data related from the ground stations. Quick look display is a very important function of data center is before even you can say doing any high level processing or initial level processing, we want to see whether we have really operated the payload in the right sense and it is seeing in the right direction, and the mode what it is operated is correct or not. So all those things would be looked at by just seeing the quick look display. Like a raw data, whatever is coming from the station immediately could be displayed. Similarly, the other activities are happening like registration, user interface, and then long-term archival, short-term archival as per the international standard to be maintained, and the dissemination initially to in operation centers and investigators, and later it would be hosted to general public. This is a typical ground segment. From the satellite data will be coming here, and then whether it is an Indian ground station or a foreign ground station, then it is coming to the payload data will be coming here to the Indian space center, and then the PC data will come here to the space center. Both are connected very tightly together here. Because for doing initial level processing, a lot of things are required from the space center, like with respect to the schedules, then there are some orbital information as well as there are some HK information like OBT, correlation things. Now after that, once data set is processed, it will be transmitted to the investigators, developers center, and then public progress. So the typical ground segment and the pipeline. And another thing is, whenever we are doing initial level processing, the onboard, whenever payload is storing the data, it is storing the data with the onboard time. But here ground, we can understand only either in IST or anything of those things. So there is another thing which is dependent on this is to see get the OVT and CIT correlations used here, and then that would be allocated. Yeah, so that would be there. 1 second. Okay. Okay. So now, to receive the data, when you are going to access the data and download the data, the ultimate thing is what? Today, you are able to access the data and you should be able to utilize it also. So, how you can do? If you have followed the right standards. So, for ISRO also, we have to keep on evaluating, keep on adopting new standards. So, every missions are actually driven by the scientific community acceptable formats. So, like suppose if we have some missions, like you see the imaging data generally is an IMG format. If it is hyperspectral, spectral, it could be in QA. Like that, for different type of that observation period could be ST5 or NetCDL. Now, if you go to astronomical data sets, it would be in FITS, flexible image transformation system. So, if it is only some spectral or program counter type of data, it may be in TAF, TXT or DAT file or in CSV also. There are different type of formats. So, the technology should be able to plug in any type of actual format, should be able to understand that, and should be able to provide the access and retrieval facility for all those formats. In addition to that, how to store this data, how long should be kept, even today it is kept even after 25 years, 100 years also, same data should be made available to other users. So in that case, there are standards like planetary data systems. I have some few slides on the planetary data systems. So planetary systems actually dictates how the data can be used in the long term. So in that, the data, the corresponding metadata, the documents, as well as the file formats, and everything is kept as a part of the data system archive management. SPICE is a thing which is actually storing the satellite related information in a standard format. So like that, there are many different standards which we have adopted and we have to follow. Now coming to this, before providing the data to the users, what are the things are happening in the underlying architecture here? So one is the hierarchy storage management, in which whenever data is coming to the data center, just to the data center, immediately lot of processing will happen. The data should be kept in high performance storage and you should have a quick access facility so that it can be quickly accessed and high input output rates would be there. So that way. But after some time, once data has been already generated, definitely it cannot be accessed. Only during case of massive generation, every processing will come to be generated. So the hardware storage management based on the policies and what access is required to keeping everything into the high performance storage. Automatically, after you can say some predefined period, the entire that access would be the data would be moved to a medium storage and then to the same tier 3 storage. So that is a concept which is called a hardware storage. So that way what happens, the most frequent and most accessible data would be kept in the tier 1 and subsequently coming out to the. And based on the mission requirements, there is high computation, high binding systems proposing, and then this everything is kept into our internal. But finally, it has to be given to users and students. So there is another layer called the simulation layer, where remote access and web are also provided and web applications are hosted. To submit both the layers, we have our own in-house terminal, one main gateway, which is like a data diode, and then one more level of security is our infrastructure access. So to cater this one, scale SAN storage and multi-homing and high throughput internet is provided. So there is a multiple internet connections out there. Remember, one in term, second will cater the download and access features for the users, and then one website and application. This is the common for all missions. But for each and every mission, whether it's in or maybe upcoming missions or Mars or missions, there is a multi-mission automated data pipeline. Each and every mission is very unique. Where the data will go, but the policies will be defined, policy-based definition will happen. Then there are for some missions, it is a scientific community driven, the personal system is in place. Then for this one, we have a high bandwidth engineer, and then send data processing, the mission environment will be created for each and every mission, and quick load display for the different payloads according to the mission, whatever is required. Then correspondingly interfacing with this requirements. Finally, the thing is science data sharing, integrate and aerospace efficiency and missions. Once you go there, this is what I was telling. This is the typical layer where first layer we have the ground station is connected, where the data is getting required from a satellite. And this is all our internal layers where we check with level and processing happening, here archives are maintained. This is outside layer where the users are connected here, there is a data from here and this one only with the data. If you see the data management technique here, these are the things where the data processing and all the things. Wherever high performance is demanded is coming here, they are connected to the SAN switch directly on a fiber. And wherever medium performance is required, they are connected to it. And medium performance things are connected to the scale of mass storage. We have all sort of technology, whether it's SAN storage, scale of mass storage identified, and other clients are connected to the LAN. We have our own software here, which is taking care of data management, SAN storage, and moving the data from SAN to SAN. And then finally, main thing is once data is generated on a seed, it should be taken. So we have enterprise class carefully. So data is going to the storage, tier 1 storage, and then going to the paper. Okay. One copy will be kept here with the time storage, and then every 4 minutes it will be taken in the case copy, and every 4 hours it is taken into the tape copy. Now another concept is called void. Every, you can say, 1 month, this is the data safe, copy will be kept here, the tapes will be removed from here, taken the world copy, the essential data will be taken as backup, new document, and then again move to the data safe. These are like webpage, form page, output, data safe. So based on the mission, there are various kinds of computing environment, there is a variety of systems, codes, and virtual machines, everything is covered. Now, most important thing is whatever data you are distributing to the users and what you are downloading here should be the best standard form. So, who will dictate the customer form? Yes, database. There are various national and international agencies. They have taken a proactive interest to standardize the necessary formats. So, so is also one of the main thing for this is flexible, interoperable, and interactive formats. So, with the IPDA, if you are interested in human data, you can also go to the IPDA website. You can also study and go through this one. So, very interesting things are happening, new protocols, new access methods are being developed, being discussed in this particular forum, and slowly all the agencies are adopting them, and that is what you can see. Into the channel. So, once the channel. So, these are the some typical things. I have first, because there are three missions in I will just take first of all. So, this is a typical overall data pipeline. When the ground stations are received here from the IDS and whatever I have shown to you. So, data is received here in our value data acquisition system. Then, after the data is ingested here, and then real-time data is sent to the QuickLook server so that we can see immediately the raw images of the whatever is captured with satellite. And then data will come here using our data movement software and file transfer system. It would be sent particular page to the model level 0. Once processing is over, this is archived, and also it is being sent to our outside layer through one gateway to SFTP for all our connected players and POCs. Similarly, level 1 system is also here, level 1 processing will happen, and this also will be sent to the corresponding POCs. Now you know that when we see moon, we are seeing only one place from moon. So, and when Earth is rotating, we can see only moon from maximum of 11 to 12 hours. Then again, other part of the time I cannot see them. So definitely what I need one more station which is other part of the moon, so that whatever my satellites are revolving around that, capturing the important data, I should be able to download. So to cater that, there is a new station which is from the JPL NASA. So this also was support was taken. It also used to receive the data from our satellite, and through the standard, another standard is called SLE. Through that SLE, data used to get and supply to us. And then again, it will be fed with entire chain. In addition to that, to further increase the visibility for a limited period, there is from Sweden Space Agency, Hawaii station also was added to this one. Since it was in a different domain, it has come through this channel to our internet, and then via this only the data was fed here to this system, and then here the entire chain was communicated. This is with respect to data and data processing. Now coming to the process which is involved to release the data. So once POC has received data here, the high level data product generation also will be carried out. Then PDS4, the planetary data standard, what I was telling, that compliance would be checked. And then science peer review by the national level committee is carried out, and after that the quality check and verifications are performed. During this process, many times science data will go for a number of reiterations, reprocessings or regenerations, or maybe a mass regeneration also will be carried out. Then after that, once everything is clear, a clear reviewed clear data set is handed over to us, and after the locking period, whichever science program office is getting for them, then data is getting released to our ISRO website. This is the website, ISRO website. I will be giving one demonstration also to you. So now coming to the data archive, you know, ISRO Science Data Archive is a thing which we have established in year 2007-2008. And for lunar missions and interplanetary missions, it is a standard which is followed with the system standard, which is as per PDA, whatever Alliance have shown. Chandrayaan 1 mass of mission actually they are in PDS 3. Chandrayaan 2 is in PDS 4. And now Chandrayaan 3 also is in PDS 4, and Chandrayaan 1 also we have started the activity of converting from PDS 3 to PDS 4. Okay. And this is the data archive, little bit about data archive. You see, ultimate thing of maintaining the standard data archive is there will be a good organization structure. So it is like ISRO Science Data Archive, in that CH2 bundle, CH3 bundle, or CH1 bundles. Then inside CH2 there is an orbiter, rover, and you can say lander in case of Chandrayaan 3. Then there are different mission phases. Once you reach there, the normal phase is declared. Before that, there will be a testing phase, earthbound phase, and all lunar phase, mount phase, all those things. Then after that, instrument. So instrument would be like this: instrument collection, and there would be some data which is continuously coming here, because you should understand once you are downloading the data, you will be getting in this format. So there would be raw and calibrated data in different data production data. But there are some data sets which are static. Static is like mission information is fixed, documents are fixed, then there are some schemas are fixed, then context of this mission is fixed. All those things for every data set, you need to attach that. Otherwise, what happens when you are downloading the data, again the repetitive information will be downloaded. So that's why what we have worked out in such a way that the static contents on the one-time contents are posted separately, and the regular data sets which you can search and download is posted separately. And once you download and extract, the structure will get created automatically. So it comprises of data, associated metadata, mission information, calibration data, detailed documents, necessary tools, and user guides. So these are the things, and data is provided separately with various options of browsing and download. This is the resource data type, where you can log into our ISRO website, you can go to ISDL, this one, or click on these missions. Once you click on the missions, you will be seeing many missions, but as of now, the lunar data, Chandrayaan 1, Chandrayaan 2 is already available, and lunar 3, Chandrayaan 3 data is just expected to be made available within a couple of months' time frame after the peer review process is completed. Now, astronomy data is already available. ExpoSat is 1st January only it was launched. So once we receive sufficient data, peer review calculate done and documented over, this also will be released. Similar thing is for IIRS. For interplanetary mass of information data is already released in our website, and you can access and start utilizing it. Or thing is, this is our grid. Once you go to the missions, these are the missions. You can click on Chandrayaan 2 and you can information on the PDFs. And next is Chandrayaan and ExpoSat also will come here once this data is released. So now you have a concept, you have an idea, and you want to work on this, your algorithm and your idea on the Chandrayaan or maybe a lunar data. So the next thing is, this data was released in December itself, available by Chairman ISRO. As of now, today's status is till now, XSM, Chase class, TMC2, HRC, IRS, the dual frequencies in the aperture radar, and this is the DXR and X5s. These are the datasets are already released on our ISRO portal, our ISRC portal. These are the number of files, and this is the volume of data. Close to 20 terabytes of the data is already available here in our corresponding website. And total registered users are 4,608. So the main thing here is some of the instruments like OHRC, optical high resolution camera, is the world's highest resolution camera which is available, including recently whatever Japan's mission of SLIM lunar mission happened. They have also taken the input from ISRO, and OHRC data was supplied to them for their landing criteria. Like that, many other missions, for Chandrayaan 3 also Chandrayaan 2 the data was used. Like many landing sites have been measured by this to the highest resolution with 25 centimeter. Similarly, the IIRS and dual frequencies are, these are the very unique instruments, and they are first of its kind, which is providing very valuable scientific data sets to the entire flow. There are two ways we are giving the data to our users. So, SFTP based and web based. SFTP is only the selected users, web based is for general public. So here you will fall under this, so you will be accessing to web based. So once we go to the SFTP based, you know this I'll skip the previous slide because it's only for PI and POC perspective. So once we go to the web based, you have to open the URL, pradhan.html, log in, register, you click on it, select payload from browser and download section. Filter the review based on various parameters, view the data, file save, select data and download. And you can also integrate with download manager. Then download user guides, tools, calibrations, all those things are available. As I told you, the regular data you can download. But if you want to maintain the data PDS structure, we have also given a PDS structure as a file. You can download in your system, extract it. After extracting, full structure will get created. And inside the data, you can keep on downloading and copying your regular data. So you will have in your system also PDS structure will get automatically created. These are references, acknowledgement, all those things you can verify. And once as a part of demo, click on this mission. Once you click on this mission, the grid will come, or you can select from here or from here. Once you click on this, this is a Chandrayaan 2 page where data. Under data, click on access data. So once you click on access data, the pop-up will come because it will be landing from website to our Pradhan web application. It will take you to the server. Once you have logged in on Pradhan.irs.org, click on login. Once you log in, this is a home page, and there are some unique features of this one. Is like you can browse the science data, you can search the data based on payload specific parameters like location, observation time. You can add multiple filters by searching. You can download the data in compressed form, pause and resume the download, group small files and download as a single file, then PDFs for combined archives simulation, and search results specific unit, like that. In fact, if you forget your password, you can click on this forget. Or if you are new registered, like students have not registered, you click on the new registration. You can click some fields will come, and then you fill it, and then you will be logged. You will be able to log in with your registered account. So once you have logged in successfully, there is a browse and download section. Click on browse and download. You will get this all the payloads listed there. If you click on any of this payload, so once you click on the payload, then you will get the table, entire data here, like here if you see. And in fact, before downloading data, in fact you want to go through the data, like user manual, you can click on this user manual will get downloaded. So you can go through this and then you can download the corresponding data. And reference URLs are also added wherever applicable in this. So for each and every data sets, whether it is imaging data, whether it's Excel data, or it is a proper contours data, there are different type of filtering methods are given. Like suppose if you go to class, there are 3 types of things. Based on that, you can do searching or filtering. Same way, if you go to the imaging data sets, there are various exposure levels, altitude, different coordinates, many other things. But if you go to the other like TMC, there are different levels of attributes. So there are different attributes and various parameters are given which are payload specific to filter out the search results. Even once the search results have come down, if one table has come, you can enhance the table, you can reduce the table so that you can export the things as per your requirement. Like here, you can go and add and delete, and you can also do multiple combination of these things like observation time, refined coordinates, finally. Between them also you can create a multiple combinations and again narrow down your search results. Then columns may also can get added, as I was telling you. Like there are these many columns are there. By default, these many are shown. You can select and click on next. It will get come here, and this table will get enhanced before downloading, because sometimes you are downloading from home or somewhere. You may have a limited internet bandwidth availability. So before downloading the assets, definitely you want to know whether really it is useful to us or to you or not. So there is a metadata available. Click on this metadata, see that it belongs to which mode, which state, which latitude, longitude, which area, all those things you see. And then see the file size. So file size is also acceptable, and metadata also is telling you it is of right area of interest. Then you click on this one and download, select and download, or click on directly as will get downloaded. So once you click on metadata view, there are 2 types of things. XML based, if you see, this type of will come. If you go and see the previous label, this way metadata is available here. Both methods are available there, and then there are some fields here. Now coming to the once you get the search results, sometimes search results will be very large. You see here, so you can go up to 10, 100 rows. This right now it is by default 10 rows. You can make it 100 rows. In a single page, 100 rows also may come. There is another, you see, once I selected 100, automatically the 100 rows, this one in one page has come. The number of pages for you, it will get reduced from, you see, 112,000 to, now it has become 11,000. So like that, it will get reduced. A very important feature is select multiple products or page for download. Suppose I have clicked on this, entire thing got selected, and down there is the option called I can download. But there is another feature for the user. What we have given is you can select here, you can write I want from 185 onwards up to 10 MB size. You select automatically. So once we give from 185 onwards till that time, because these files are very small in size, till the time it is reaching up to the 10 MB, it will automatically select everything up to 639 and then click on this and you will be able to download entire 10 MB data. This is the last that you see, 185 to 639. It will take some time because it has to create a separate zip for you so that you can optimize the download as a single file and the compression. So in addition to that, once we go to the PDS archive in user system, this is the PDS viewer is stored. So everything is a PDS compatible data set. So you can go to the PDS viewer, there is a separate page available. But in addition to that, to maintain the PDS, you can download the ISRO mission bundle, download, extract, and create the archive into your system. You can download PDS viewer. Once you download and you start using, this is the view. Go there, open the set data sets, click on this, give the values as per the user manual, and you will be able to open the data. You can zoom within and play around. That will be the data sets. Now, once we click on this, there are other downloads. Definitely, what happened when I told that it's a bundle you create and you get the data. Now, for each and every specific payloads, there is in that section we have like IIRS. I have just extracted this. If you open this IIRS, inside IIRS, browse, bundle, calibration, data, document, all those things will get created automatically as a part of IIRS. This everything will get created in your system automatically. Only thing what is not there is data and browse. So what happened when you go and download the data from our data portal, and you have to copy the data inside this directory. So that already the structure is maintained, entire thing, and when you click on copying that into this one, then automatically you will have a PDF structure ready, and then use the PDF viewer, everything you will be able to use seamlessly. If you go to the under download for common PDF structure, common tools, and then after that one by one, all payload specific options are given, like here, and then references for some of the journals, some popular papers, and some of the documents which is required, and calibration things which is required for users to use the data sets and help in their analysis. Even if you go and click on this corresponding section, you will be landing on the corresponding section itself. Now coming to the other download section, one I've just given a screenshot of other payloads. I'm just scrolling down. So like that, all payloads specific sections are given here. Now once we click on this section, each and every section, each and every payload is having its own user manual. AP, XSM, then IRS, and then SAR, then class, PLC2, JS2, and this one is also given here. This is the overall document. You can also go and click on history and statistics. So whatever you have downloaded earlier, you can see your downloaded statistics and history, whatever it is you have downloaded. Now, what we have seen is a lot of students and users, they will have some of the questions. So to reduce the number of queries and interaction and dependency on us, what we have done is mostly whatever queries are coming from the users and popular questions in a science perspective or a data access perspective, we have already given a lot of questions here, like common questions and payload specific questions before that. So if you go to this FAQs, like I'm facing issue when trying to download the data by clicking on the files, what kind of. So like that, we have already given a lot of popular FAQs. So you can go through most of your queries will get answered by using this all these FAQs. Now, see another set of like a lot of questions are already. Whenever you are using the data sets as per the quarters or ISRO guidelines, there is a acknowledgement statement. You can always refer to the acknowledgement statements whenever you are publishing any paper, in passing over data sets in a public forum, and then always mention this. Now coming to disclaimer, in any of the data sets, anything is there which need to be pointed out, or something is assumed and not provided or something, those things we are posting and updating in the disclaimer section. With respect to the payload specific things, when you have any issue to download access, you can contact ITC. And with respect to the science analysis, there are managers, PI and POCs, their email IDs and names are here. You can contact and you are free to discuss with that. They will be guiding you on these fronts. This is for each and every payload. Now, in addition to that, one more new feature has been made available. This is only for our optical payloads. So, like if you go there, it is called Chandrayaan-2 Data Map Browse and Download application. If you click on this, it is already available here. Even front home page also this feature was there. So you will be landing on to one more interface that is called Map Browse. It is like a Chandrayaan Data Explorer. So once we go there, click on reticle, all the reticle will get created. So because most of the time people are telling I know particular data or something, I will go to that place and whatever data sets are there, I want to download that. Matter to that, this entire right now whatever is available. Suppose I have clicked, there are so many data sets. I just click IRS data sets. So whatever IRS data sets are there, those are already got plotted here. Now what I do is I'll just select one area. I have just selected one area. In that next section, I have given selected some small area. You can select up to 5 degree, 10 degree type of regions. So then in that area, these two data points are clicked. I can select and download. I can select both and download. Both options are there. Or what I can do is, I can make one small square here. In this square, when I made very small square, these three strips are coming into this when I have made a small. So when I do, there are multiple data, see 1, 2, 3, 4. In this region, multiple are there, they are overlapping. The entire list has come here. So once I am clicking on the list, I can download the data sets. This is Chandrayaan Data Explorer and Resolution tool, which is also posted on the website and users can access. Now in that, I want to download only one. I clicked on this particular data set. Once I clicked on this data set, there is this page here. And click on download. Once you click on download, you will go here and get downloaded. So once you download it, the structure can be maintained. Now coming to Chandrayaan 1, because Chandrayaan 2 I have given a very detailed demonstration. So this is Chandrayaan 1. Chandrayaan 1, you know, there are total 11 payloads were there, and I think that Dr. Pandey might have already given a good briefing on this. But here now, with respect to this one, these are some popular data sets, and you know Chandrayaan Moon is always tightly locked to us, which we are always seeing the near face of the moon. Our sight is not at all possible for us to see from even by the man's naked eye, telescope and other things, because we are always seeing one side. So it is only possible through the man-made satellites or which type of satellites only, which is revolving around. So there are few far-sight images also were captured by Chandrayaan, far-sight image of the moon. This is before just a touchdown. Some of the MIP frames were taken. Now, all these data sets, if you want to download, what you can do is go to the IGC website and okay, something is hidden here. Okay, go to the IGC website and go to Chandrayaan 1, click on data, similar style, whatever I have told, and then you will get all these features here. So, since Chandrayaan 2 already have demonstrated in very elaborative manner, I'll just tell here, we have also hosted Lunar Atlas. You click on this, there is a very good PDF of around 1995 only. You can download. All images with nicely annotated this one corrected that is available. You can also search TNC high data products that is on this based on date, time, latitude, longitude, all these features are there. Then there are availability of opportunity payloads. You know there are some payloads which are by India and some payloads from the other institutes and other agencies. So once you click on your payloads, you will be able to search Tara, Swin, Sina and all other payloads that are from there. And there are two types of gems are made available here. One is 25 meter gem and the 10 meter gem. So based on your area of interest, you can just click on this, the search options will come and you can download. Then there is called Access Catalog. So full entire whatever images have been acquired with Chandrayaan, where a detailed catalog was made, that is also posted here. Now to analyze the data and understand the data, the supplied information is also required, that is size data is also released. So what we did is, because these data sets are not very large in size, and when you want to understand this, students and users want their data, so it is small in size. So what we did is we made entire zip. So it is very small size, you can download the entire zip itself instead of giving a further build of search option. Same way LLRA data also, it is provided as an entire zip. MIP data also is provided as an entire zip. Whatever frames, when the probe was released from the orbiter and it was going towards the south pole near the shuttle data, so during that journey, whatever the frames were taken, all the frames we have put and made it as zip file and it is made available for the understanding. And there is a reddown data also there, that is also we have posted. Now in addition to that, there is a mosaic, that is a polar mosaic and equatorial mosaic. Those things are also hosted. Click on plus and you will be able to get a search view. And then global view. Once you click on global view, there is another application that opened, which will give you here also map browse type of features. and then you can search the products on that. Now downloads, and then there is another collaborative payload was there, which is with the NASA, Incube and Lunar. So if you see MIT data, then Chase data, and then Chase, if you go there, that will come here, collaborative mission undergo, and then ISRO data and Incube and Lunar. These all have contributed in ensuring that there is a presence of water on surface. And then acknowledgement statement. As on 22nd, there are 187 users, and it is cut around close to more than 18,000 downloads have been done. Now coming to the Chandrayaan-3. Overall, there are some 5 science payloads. Chastity almost 1 million sets. This lunar day, which is 14 days of activity. It is around 230 data sets, Ramma around 220, Net 33, FX 30, and NAFM were some 50 plus images, and total 45 plus mobility was carried out. Science data, almost 22 GB of science data is required, and distance traveled is around 100 plus meters. So science payload and camera operated using lander is lander camera is lander imager, rover camera is navigating camera, and rover imager. But payload wise, these are treated as a sensors to carry out the operations. Payload wise, Ramban Chastity is and rover payload is APXS and LIMS. These are the images you must have seen, and this is the website which you can note down and access data. So this is expected to be released very soon. That activity, the review of the entire technical as well as scientific perspective is already going on. Now with that, wherever that Chandrayaan-2 touchdown happened, which is called as Langa Point, and wherever this our Chandrayaan-3 landed, which is called as a ship. And the of us when Chandrayaan-3 successfully landed on this list today is now being celebrated or being celebrated as a national space. Okay. And India was the first one to land on this South Pole region, and fourth country to achieve soft landing. And today early morning around 4 o'clock, there is one more commercial private mission which is collaborated or initiated by NASA. TP Mission 1, they have also landed in the Malapad air region. You can also search about the TP Mission 1. So, moon surface after a long period.